Okay, so continuing on with geometry type questions, this one was on the 2019 paper, and there was two quite long enough questions on the 2019 paper on geometry, paper 2 that is. The diagram below is made up of two equilateral triangles and two parallelograms. Okay, three angles are marked, N, M and K. Okay, so a couple of things, triangles for a start. Just a refresher on triangles. So if you remember, you have an equilateral triangle, and you know now mine isn't going to look equilateral, but I'll do my best. Okay, so equal sides, equal angles. Okay, so that's equilateral triangles. Okay, we then have what's called an isosceles triangle. Yeah, it didn't look much like a triangle. Okay, let's try again. There. Okay. Now, still doesn't look equilateral, but anyway, so isosceles. So isosceles triangles has two equal sides and two equal angles. Okay, and it's the ones opposite the sides that are equal. So they're the two angles that are equal, sometimes called base angles. And then the third type of triangle is the easiest one for me to draw, because it doesn't matter how I draw it as long as no sides or angles are equal. Okay, so they're the three types of triangles that exist: equilateral, isosceles, scaling. So what do you need to know about them? Sorry, just a cough. What do you need to know about them then for junior cert? Okay, well, in an equilateral triangle, you have equal sides, equal angles, okay? So if you remember, what do angles in a triangle add up to? They add up to 180 degrees, okay? So the angles in an equilateral triangle then must be 60 degrees each, okay? Because they're equal angles. So the three angles there are 60 degrees. Isosceles triangle, in many cases, they give you this angle here, and then they ask you to work out the other angles, or maybe just one of the other angles. And in that case, you have to subtract this angle from 180 and divide by 2 to get the other two triangles. Okay, so that's an isosceles triangle, and that's the type of questions they ask. And then in a scaling, all the three angles will be different because all the three sides are different. Okay, what you'll find in any triangle, right-angled, equilateral, isosceles, scaling, anything, that the longest side will have the biggest angle across from it. So the biggest angle is always opposite the longest side. And what you'll find is the smallest angle is always opposite the smallest side. Okay, and that doesn't matter what type of a triangle it is, that property exists. Okay, then within any triangle or within any shape, you have a few different types of angles. And the three named here, they have an acute angle, a reflex angle, an obtuse angle. So an acute angle is less than 90 degrees. Okay, so it's a small angle less than 90 degrees. So between 0 and 90 is what we call an acute angle. Acute is another word for sharp, so it's like a bit of a sharp angle. Obtuse angle I'm going to do next then is an angle that's bigger than 90, but less than 180 degrees. Okay, so it's somewhere between 90 and 180 degrees. Okay, so if we go up in size in our angles, we have an acute angle, we then have a right angle, which is equal to 90 degrees. We have an obtuse angle, and finally we have, then we have a straight angle that's equal to 180 degrees. And then finally we have a reflex angle, and a reflex angle is bigger than 180, but less than 360 degrees. Okay, so to summarize that, we have, I'll do my angles over this side. We have an acute angle, which is less than 90 degrees. We have a right angled equal to 90 degrees. We have an obtuse angle that is somewhere between 90 degrees and 180 degrees. You then have a straight angle. It's equal to 180 degrees. And then finally, you have a reflex angle that is somewhere between 180 degrees and 360 degrees, okay? And then 360 degrees then is a circle. Okay, so in other words, if you think about it, you have two straight angles back to back, so it's like two protractors, so it's 360 degrees. Okay, so they're all the different angles that you need to know. Okay, so that's a summary of the theory behind triangles and angles. Okay, so it just depends on what you picked up along the way. Some of this, some teachers touch of it in national school, others may not. Okay, so do let me know if you need more theory on any of it. So let's have a look at this one. The diagram below is made up of equilateral triangles. So when I look in here, then I'm looking for the triangles. So this must be what's called an equilateral triangle, and so must this one, because they're the only two triangles in it. So they're both equilateral triangles. In other words, their angles are all 60 degrees. Okay, okay, all angles are 60 degrees, okay? Where did I get that? 180 degrees in a triangle divided by 3, and that's where I got my 60 degrees, okay? And then two parallelograms. So a parallelogram is a four-sided shape. It's like a rectangle pushed sidewards, okay? Opposite sides are equal in length on a parallelogram. So I'm going to, at some stage, give you properties of all of these shapes. Opposite sides are parallel. Yeah, so that's your parallelogram. And then there's the angles. Okay, so part A then says write the correct letter in each space in the table below to show what type of angle is each one. Use each letter only once. So my acute angle is my small angle. So it has to be K. My reflex angle is N. It's the one greater than 180, but less than 360. And my obtuse is between 90 and 180. So it must be that one there, because if I go straight up, won't I have my 90 degrees angle? So you can see that that one is greater than 90 degrees. So there's your three types of angles. It then says work out the size of each of the angles K, M, and N. Okay, so I'm going to do K first, okay, because K is 60 degrees, okay, and it's 60 degrees because, okay, I'm going to write out the answer as I would in an exam, okay, so this is the type of exam answer I would give. So I would give K is 60 degrees, and I would say equilateral triangle, all angles equals 60 degrees. Because remember what I was saying last week or earlier this week, there's no real maths in it. It's proofs and statements, okay, and axioms. So you have to write down the answer, but you have to write down why. That is super important. Okay, the next one then I'm going to do, I think, is M, because I see, remember I called it a protractor in the last class. I see a straight angle. Do you see that? So let's go M. So it's 180 degrees because that's my straight angle minus the 60 degrees of K. So it's 120 degrees. And my reason for this one is a straight angle. Okay. And then finally N. Okay. Well, just like I said, a circle is 360 degrees. So 360 degrees minus this angle here. And remember, this is an equilateral triangle, so this is also 60 degrees over here. So it's 300 degrees. And my reason why, 360 degrees in a full circle. Okay, so that's how I would answer B, the answer, but more importantly, the why. Why is it what I'm saying? Okay, and that's very important in any geometry type question. Okay, the two equilateral triangles are not the same size as each other. Yeah, well, that's easy enough to see there, okay? Siobhan says the two triangles are similar, but they are not congruent. Give a reason why the two triangles are similar, okay? Well, we did a good bit of this last week, okay? So the triangles, similar triangles, pen doesn't want to write, similar triangles have equal angles, okay? Both of these triangles are equilateral. Therefore, in both triangles, the angles are all 60 degrees. So again, we're just repeating what's on the other page, but we're doing it in the context of similar triangles. Therefore, angles in each triangle are equal. Therefore, I'm going to use maths language this time for therefore, similar triangles. Okay, or anything to that effect. It doesn't have to be an exact copy of my words, but you see what I'm trying to do, okay? When you're asked to show that something is a similar triangle, or two triangles are similar, you have to show that they have equal angles, okay? So that's what I'm trying to show. That's the theorem, I suppose. That's the proof that I'm trying to give you. And then I go on to explain why the angles equal each other, okay? And just in that context, explaining what an equilateral triangle is. Now, part 2, give a reason why the triangles are not congruent. So this one asks you to explain what congruent triangles is. And again, last week, we were discussing the difference between congruent triangles and similar triangles. Now, we've done no questions on congruent triangles yet, but congruent triangles have equal angles and equal sides, okay? They're an exact copy of each other, the two triangles. Okay, because the two equilateral triangles, I'm actually up here ticking down their words. Look, I'm going to use their words. I always use their words in a question. Equilateral triangles are not the same size as each other. Then they cannot be congruent. Okay, so I hope that makes sense, and you have to be very comfortable in especially paper 2. If you get asked a question in English, you have to answer it back in English. Okay. D. The small triangle in the diagram has lengths of side 4 centimeters. The big triangle has sides of length 8 centimeters. Use this information to construct the diagram in the space below. Show clearly any construction lines used. Okay. So basically, it's asking you to draw a construction of this, okay? And I have promised you to do some videos on constructions. I haven't forgotten that. I'm probably going to do them during the midterm week. Okay. So they're asking us to draw that, okay? So what you'll see when I do the constructions is we'll end up drawing a triangle, okay? So I'll draw a baseline here, and using my ruler and my compass, I will, well, no, with this one, I will use my ruler to measure out 8 centimeters. Okay, so that's easy enough. That's this line here. I then use my compass to measure out 8 centimeters. And what you do is you put the needle of your compass in here and you draw an arc up here that's 8 centimeters long, okay? And the thinking being anywhere from this dot to anywhere on this arc would be 8 centimeters, okay? And then you do the same from this corner. You come in and again, you draw an arc from this side, okay? And where these two arcs meet is 8 centimeters, okay? Like that. Okay, and then these become the construction marks that they're talking about, or construction lines, and it's these construction lines that gives you an awful lot of marks for these questions, okay? So that's why you can't do it with the ruler, you have to show the construction marks, okay? What I would do then is using my compass, I would short it down to 4 centimeters, and I would continue on along this line. And again, I'll just change color. I would draw an arc of 4 centimeters. Okay, so that's that point there. I then come out from here and draw 4 centimeters. Okay. And then you draw that. Now it's not going to work for me perfectly here, okay? And then we'll end up drawing parallel lines here in a parallelogram. That's another construction on your course. And of course, all being good, that one didn't work so well, all being good, we would have our parallelogram in this side too, but you can see mine is crooked because my lines aren't even. Okay, so there's 2 constructions on your course, a parallelogram and triangles, okay? So we'll do both of them and we might even come back and draw that. But if anyone has done constructions, do feel free to send me a copy of that and I'll check it for you. Make sure you have all your construction marks in. Okay, and that was that question.